particle A and B of mass 0.32 kg and 0.48 kg respectively. Okay, the masses are given, so I'm going to draw the weights on the diagram. For A, the weight is going to be downwards, which is going to be 3.2 newtons from mg. Okay, so this is 3.2 newtons, and there's going to be a tension upwards. At B, there's going to be tension towards the left and weight downwards. The weight is 4.8 newtons, and there's going to be normal contact force here. And if friction is mentioned in the question, we're also going to draw friction towards the right. Okay, this is R. Okay, back to the question. The particles are attached to the ends of light inextensible string which passes over a smooth pulley fixed at the edge of a smooth horizontal table. So no friction. Particle B is held at rest on the table at a distance of 1.4 meters from the pulley. A hangs vertically below the pulley at a height of 0.98 meters above the floor. A, B, the string, and the pulley are all in the same vertical plane. B is released and A moves downwards. Okay, this is the direction of motion that A moves downwards, B moves towards the left. Find the acceleration of A and the tension in the string. Okay, so for part A, I'm applying Newton's second law on A first, which is forward force minus backward force is equals to m times A. And now I'm applying Newton's second law at B, which is again forward force, which is T minus, there's no backward force, 0 is equals to mass, which is 0.48 times A. Okay, you solve these two simultaneous equations and get the value of A and T. This would come out to be A equals 4 and T equals 1.92 newtons. And A's unit is meters per second squared. Okay, part 1 is done. A hits the floor and B continues to move towards the pulley. Okay. So now, after a while, A will hit the floor. That means B would move the same distance towards the left. This is 0.98. And then this remaining distance would be what? 1.4 minus 0.98 is 0.4. Okay. Now, find the time taken from the instant that B is released for A to reach the floor. Okay, how long does it take A to reach the floor? For A, we know U is 0, we know S is 0.98, and we also know its acceleration, it is 4. We found it already, and now we need the T. So we can use S is equals to UT plus half AT squared. For part 2, S is equals to UT plus half AT squared. S is 0.98 is equals to 0T plus half AT squared. Make T the subject. You'll also have to take square root in the end. And you would get what? You would get 0.7 seconds. Okay, so it takes 0.7 seconds from A to reach the ground. Okay, that means it takes 0.7 seconds from B to reach from this point to this point. So this is also 0.7 seconds. Okay, now we need the time from the instant that B is released till B reaches the pulley. Okay, so we know this part of B's journey. Now we need the remaining part of B's journey. It's telling us that B will actually hit the ground, hit the pulley. Okay, so for this green part of the journey, what do we know so far? We know that its U is going to be the speed with which A reaches this point. Whatever is the speed here is going to be the B speed here. So let's find V for this. Okay, so we can use V is equals to U plus AT. V is equals to U plus A. T came out to be 0.7. So V will be 2.1. Sorry, 2.8, not 2.1, 2.8. This is 2.8. That means this value here is going to be 2.8 as well, the speed. Okay. And for the green journey, this will now be U. U will be 2.8. Okay. So for the second part of the journey, we know U is 2.8. We know the distance to be covered till it hits the pulley is 0.42 meters. And we need the time. And once we have this time, we're going to add it to the yellow journey's time, which is 0.7, and get our final answer. Now, to find time, we also need acceleration of this part of the journey. Okay. Now, how do we find the acceleration of the green part of the journey? A hits the floor. Since A hits the floor, the the string will become slack. It slacks and it pulls the pulley towards this direction. So since the string is slacked, its tension is now zero. So when we use the formula forward force minus backward force is equals to MA, that is this formula, we now use forward force is now zero. Backward force was already zero, is equals to mass, which is 0.48 times acceleration. This just gives us zero. Acceleration is zero in this part of the journey. Okay, so acceleration is zero. Now what do? We just need the time. Okay. Now the speed is going to be constant. So you can also use the O levels formula. Speed is equals to distance over time here because the speed is constant because the acceleration is zero. Or you could use one of the equations of motion and put acceleration is equals to zero, get t as well. So I'm going to use the O level formula. V is speed is equals to distance over time. Speed is equals to distance over time, or this is also written as S is equals to VT, where S is the distance. So distance is 0.42, V is 2.8, the constant speed, and T is the time. This will get us T equals 0.15. And the total time it takes B to start moving and hit the ground would be 0.7 plus 0.15, which is 0.85 seconds.